Good morning. Okay, today in math we are going to talk about how mathematicians can divide fractions by using the reciprocal. And I'll explain what that means here in a little bit. First of all, let's just start to divide up using a whole number. We're going to take a whole number divided by a fraction. And I want to try to give you examples of real life things that we might have to divide into fractional pieces. So let's say that we have 3 lasagnas. There's a lasagna. Try to make them about the same size. Okay, these are our lasagnas. And we're going to cut those into thirds. How many 1/3 are in 3? 3 divided by 1/3. Because I'm taking 3 wholes, 1, 2, 3, 3 whole pans of lasagna, and I'm dividing them into thirds. Let's get another color. Divide them into thirds as equally as possible. There's 1/3, 2/3, 3/3, 1/3, 2/3, 3/3. So I broke this up into thirds, second one up into thirds, and the third lasagna up into thirds. So how many 1/3 are in 3? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 1/3. So 3 divided by 1/3 equals 9. That's interesting. Because I know that 3 times 3 is 9. I wonder if that has anything to do with anything. Let's look at another example. Let's talk about pie. What if I have 6 pies? 1, 2, 3, 4, 5, 6. I have 6 whole pies, and I'm going to cut them in halves. I'm going to cut each one in half. So there's 1/2, 2/2. 1, 2. There's half, 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 and half. So the problem that I just represented was 6 whole pies divided by a half. So that question is how many 1/2s are in 6? So let's count the halves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do you notice anything? Maybe the same thing I noticed up here. 3 times 3 was 9, and here 6 times 2 is 12, but we're dividing. Why does it kind of seem like multiplication? Let's look at another example. Make some room. If I've got, let's say I've got 5, I don't know what else I can cut in. Brownies, pans of brownies. Oh gosh, let's use brown for brownies. If I've got 5 pans of brownies, there's 1. Maybe it's a square pan. 2, 3, 4, 5 pans of brownies. So my problem is 5 divided by. Let's cut these into fourths. Let's divide each one into a fourth. So 5 divided by 1/4. So let's cut these into fourths. This way and this way. Oh, squares are easy to cut into fourths. This way, this way. 1, 2, 3, 4. 1, 2, 3, 4. There's a half. And there are fourths. So how many 1/4s are in 5? 5 wholes broken up into 1/4. How many fourths do we have? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Do you see a pattern? 5 divided by 1/4 is just like 5 times 4. Let me explain why. Division of fractions is really just multiplication of fractions. We know how to multiply fractions. We just multiply the tops and we multiply the denominators. When you're dividing and you're using a whole number, how do we make a whole number into a fraction? We put it over 1. So 5 is our whole number, 5 over 1, times, I'm going to change that division symbol to a multiplication symbol, and then the 1/4, I'm going to turn upside down, 4 over 1. Now I'm just going to multiply my fractions. 5 times 4 equals 20 firsts, or oneths, and that's just 20. Let's go back up and do it to our other problems. So I had 6 divided by 1/2 equals 12. Let me see that. So let's see. Down here, I put my whole number over 1, so I'm going to keep that first number the same. So it would still be 6 over 1. And then I'm going to change my division symbol to multiplication. Now I'm going to flip my second fraction. That's what we did down here. It was 1/4, and then we flipped it to 4 over 1. So we've got 1/2. I'm going to flip it to 2 over 1. So now I've got 6 times 2 is 12 over 1, which is 12. Okay, and let's double check this one. So if I have 3 divided by 1/3 equals 9. So I'm going to keep the same number as my first number. So that would be 3 over 1. I'm going to change my symbol to multiplication. And I'm going to flip my second fraction. So it was 1/3. Now it's going to be 3 over 1. 3 times 3, my numerators, is 9. 1 times 1 is 1. 9 oneths is just 9. So this fancy word reciprocal, mathematicians can divide fractions using a reciprocal. That reciprocal just means a turned upside down fraction. Whatever second fraction you have, we're going to flip it upside down. And that's the reciprocal. So 1/3 is the reciprocal of 3 over 1. It's just the opposite. Let's look at a few other examples that you're not going to be able to see as clearly. I'm just going to write these on the board. Let's say I've got 4 pies. I'm not going to draw a picture this time. Let's say I've got 4 pies or something, and I divide them into 2/3. So 4 divided by 2/3. Let's see if that rule works. Some people remember it by saying keep, let me scoot that over. Keep, change, flip. Keep, change, flip. You probably can't see that. There was a terrible glare. Sorry. So I'm going to keep this first number the same. How do I turn it into a fraction? Whole number I just put over 1. So I'm going to keep that one the same. I'm not going to flip it. Keep, change means change the symbol. I'm not going to divide anymore. I'm going to multiply. So I'm going to change the symbol. Now I'm going to flip the second fraction. I'm going to get the reciprocal of this fraction. So the opposite of 2/3, I'm just going to flip it, is 3 seconds. So now we just multiply our numerators. 4 times 3 is 12. And we multiply our denominators. 1 times 2 is 2. Now I've got an improper fraction I've got to take care of. It's top heavy. This is just 12 divided by 2. That's all. Fractions are just division. You just watched a video about that. 12 divided by 2 is 6. Now let's double check with a picture. Are there 6 2/3 in 4? So let's have 4 circles. I said pies, right? And I'm going to split them into 2/3. So let's split them into thirds. And then we're going to count up the 2/3. I'll shade them in red. So how many groups of 2/3 do I have? There's 1/3, 2/3. I'm going to tally. That's one group. 1/3, 2/3. That's 2 groups. 1/3, 2/3. That's 3 groups. 1/3, 2/3. That's 4. 1/3, 2/3. There's 5, and here's my 6. 6 groups of 2/3. Let's look at one more. Let's do 3 divided by, let's do fifths, 2/5. So, keep, change, flip. I'm going to keep my first number. You always keep your first number. So that would be 3 over 1. What do I do with the symbol? Change it. Change that. We don't want to divide. Division's hard. We're going to multiply. Next fraction, flip. So it was 2/5. Now I'm going to do 5 seconds. Now I just multiply. Multiply your numerators, multiply your denominators. 3 times 5 is 15. Denominators 1 times 2 is 2. Improper fraction I've got to take care of. That's 15 divided by 2. You may need to work out 15 divided by 2. 2 goes into 15. Let me move that down. It's going to be 7 times. That would give me 14. So I'm left with 7 1/2. So I'm going to write that over here. 7 1/2. I'll move my board. Let's double check that one with a picture, because this is the first one that we've gotten that isn't a whole number as an answer. So let's see, I started with 3. Let's do rectangles or something. 1, 2, oops, I want them to be kind of the same size. 1, 2, 3. I need to split them into fifths. So 1, 2, 3, 4, 5. Pretend they're all the same size. 1, 2, 3, 4, 5. That was good. 1, 2, 3, 4, 5. So I split them into fifths. Now we're looking for groups of 2/5. So I'm just going to kind of circle them and tally over here. There's a group of 2/5. There's 2 more fifths. Now this one, I'm going to connect with this one to make a group of 2/5. There's a group of 2/5. There's a group of 2/5. Here's 2/5. Here's 2/5. And then I'm left with 1, which 1/5 is half of 2/5. So I'm left with half of a 2/5. So I got 7 1/2, which matches my answer. Keep, change, flip. You're going to practice some of these problems. Feel free to write that on your boards. Keep, change, flip. Keep the first number the same. Change the symbol to multiplication. Flip your second fraction. That's called the reciprocal. Good luck.